project part. This is part 3. So Russia still uses the same stuff from the Apollo era. Yeah, that's right, because most of that stuff was built very, very well because it was the people that figured the stuff out, Stellar. It wasn't somebody who studied it retrospectively. The people that figure it out they're going to know the source material better because they invented the damn source material. But I digress. Anyway, Tars, Saturn. So, the honest question is, I don't know. I have no idea. It really, I mean, it's very clear that, scientific research rockets are subject to political winds, right? Obviously. That's why we got the space shuttle. That's why we lost the space shuttle. That's why we got SLS. I get it. However, if we're going to entertain the idea that Saturn V, we could have just, they would have just kept funding the Apollo program, which, believe it or not, dude, I think that it would have ended up, even with all these iterations that I'm going to talk about what I think could be done with the Saturn V, I think that it probably still would have ended up being cheaper than the shuttle, even if you were throwing away rockets. And they were looking at reusability studies for Saturn vehicles. That's kind of what led them into doing the space shuttle. It was born out of lifting body research, first stage S1C reusability studies, etc., right? So if Saturn V, let's just say the political ones didn't change and they just kept going with the Apollo program, what would Saturn V look like? I think it would be a very long while, dude. A very long while before we would need a new rocket. Saturn V probably would, and this is just like looking at an alternative history where the Apollo program was like 100% successful, right? Which it was until they canceled it, but I digress. Apollo 1 is the kind of asterisk on that. But, the Saturn V probably could have operated for another 20 years, probably well into the 80s. That's without iterating on it, dude. Now, think about, the first Saturn V, so SA500F, which was structural test articles, but they were super high fidelity structural testing articles. You think about the first Saturn V built, and you think about the Saturn Vs that are left today, the ones that were built in 71, 72, and 71 and 72, right? So the Apollo 18, the Apollo 19, the Apollo 20 Saturn Vs, the Saturn V that launched Skylab, for instance. You think about the ones that were built at the latter part of the block buy for Saturn Vs. Even those rockets were capable of, that's what a lot of people don't know. The Saturn vehicle went through a lot of rapid iterative changes from Apollo 11, even Apollo 11 to Apollo 17. They basically had a Block 2 version of Saturn V. And that Block 2 version afforded them more payload capacity. That's why the later Apollo missions, 15, 16, and 17, have lunar rovers on them. And were capable of carrying enough commodities to be able to stay up at the moon, landed on the moon for 3 days instead of 20 hours, like Apollo 11, 12, and 14. Apparently they fixed the buoyancy in Stormworks. The boat should work now. Yeah, I heard us. So, where could Saturn V have gone? I mean, even in the, 5 years that Saturn V was an operational vehicle, from 68 to 73, they had already increased the payload capacity by a couple thousand pounds. So, if they increased payload capacity by 4,000 pounds, that's 2 metric tons. That's 2,000 kilos. That's ridiculous. Now, 2,000 doesn't seem like a lot. And if we're just going to low Earth orbit, that's nothing. But if you're going to the moon, that's something. That is a significant increase. So, where could Saturn V have gone if they had kept using Saturn V, Saturn 1B? Oh, dude. Some of the iterations that came around in the 80s for manufacturing really would have boosted Saturn V into the next level. Saturn V could move 120 tons to LEO. Like Skylab, for instance. I mean, Skylab's freaking huge. Dude, I'll bet you they probably could have gotten up to 150 all day. They could. There were. Long story short, there's plenty of stuff that could have been iterated on from the baseline Saturn V. We already started to see it. Now, you bring in composite inner tanks. Heck, not even composite inner tanks. You like a Saturn V that stir welded with an aluminum iso grid, like how SLS's core is made, would be an insanely capable launch vehicle. They could literally shave probably like 5,000 to 10,000 pounds off of each stage, and it would actually end up being stronger and lighter. I'm talking about like using modern manufacturing techniques to make one. Because, dude, that Saturn V was literally made by, like, don't get me wrong, it was made in a factory, right? The S1Cs were made in a factory, but it's literally dudes just welding TIG welding aluminum panels together. There are no stir welding jigs. There are no jigs. And even the jigs that they do have is just, they have a dude up there with a TIG welder just welding aluminum panels together. Like, heck, all the components for the Saturn V were machined by hand. Like a guy on a lathe turning the knobs to make sure the part is machined correctly. Think about how different and how much easier and how much more reliable a Saturn V could be using CNC machines and a friction stir welding jig to do the same thing. You could shave off tons of extra mass, tons of, like, thousands of pounds of welding bead, right? And if you have a milled aluminum iso grid, you wouldn't need an internal structure. You wouldn't need internal stringers like what they had on the Saturn V. Saturn V basically had a bunch of cables inside of the tank to make sure that the tank doesn't do this. Seriously, like they cable strapped like one end to the other. Like, go look at some pictures of the stringers. It looks like a freaking suspension bridge in there. Right? So if you think about like stir welding, using partial composite inner tanks and inner stages, even a reduction of mass for guidance systems, right? Dude, yeah. I think Saturn V with small iterative upgrades, it could have operated. We probably could have kept using that thing and just upgrading it and upgrading it and upgrading it well into the 2000s. I would say, like, yeah, well into the 2000s, easily. Yeah, at least the 90s, at the very, very least. It was that freaking good out of the box, dude. It's a great launch vehicle. Hey, Slow, what's going on? Raised has a 63-month resub in there. How much time would it take for NASA to make a new Saturn V in 2023, knowing exactly how everything works? I suppose it would be much easier. Squall, I hear a lot of people talk about this these different things. Like, oh, a lot of people throw it around like it's some crazy, mysterious fact. Like, we lost the plans to the Saturn V. We don't know how to make it anymore. And then other people use that as kind of like a justification for how, we don't do stuff like we did in the 60s. It's like some idolization of nostalgia. You're looking at history through rose-tinted glasses, right? Like, don't get me wrong. I understand that it's easy to get disgruntled when you look at how SLS is kind of panning out. Yeah, I'm not going to sit here and pretend like I don't see that. It's just like, really? Okay. But remember, the premise of this conversation is manufacturing, right? Could we make a Saturn V today? Sure. Why not? It's not that we lost the plans. NASA has the plans. They have all the blueprints. What we lost is the institutional knowledge. Remember, I said Saturn V was machined by hand. There's no automation with Saturn V. Saturn V was made by a bunch of dudes, and a bunch of dudes at Michoud with welding jigs and your hands, like literally TIG welding stuff together, right? That's where the knowledge got thrown out because they didn't document it. The reason why they didn't document all that stuff is because they were in a rush to get to the moon before the Soviets. So none of this, like exactly how to weld these panels together, was really documented. The reason why it wasn't documented is because we didn't think we were going to stop going to the moon in 1972. That's the reason. Like, they were like, okay, we got to do this now. We'll get all this down later. And in that regard, like I said, Saturn V is ridiculously over-engineered for what it is. And that's how I know that you could squeeze so much more performance out of it. If you look at the rate of the rate of performance increase, so total mass down to the surface of the moon from the beginning and the end of the Apollo program, right? That's a huge number difference. I mean, I talked about it already, but that's a huge freaking difference. It's a huge difference. And if that rate of iteration is indicative of where Saturn V's design could have gone, dude, I don't see why Saturn V, with, stir-welded aluminum milled isogrid panels, right? Carbon composite aluminum interstages and, carbon composite fairings like Falcon 9. 150 tons to Leo. Easily. Hey, Chief, what's going on? Although there used to be a mentality of craftsmen guarding their secrets. Yeah, human, that's true. We didn't lose the plans, we lost the wisdom. So, that right there, Squall, losing the institutional knowledge, right? That's why we're like, it gets tossed around all the time. But that's the reason why people are like, we can't build the Saturn V. Bull crap, we can't build the Saturn V today. Of course we could. We absolutely could. But if we were going to do it, we'd have to start basically where NASA started building the Saturn V in 1964. We'd have to do all the tests for it again. All the iterative testing, the dynamic testing, using modern manufacturing techniques, because the way people made rockets 50 years ago is not how they make things now. I mean, heck, look at cars. Look at cars from the 60s, which I like a lot better. Look at cars from the 60s compared to a modern car. They're not even... The only components that are even remotely similar that they share are wheels and tires. They're manufactured in a completely different way. And that's fine. Whatever. I like cars from the 60s. I think they're cooler looking. Sorry. Anyway. Because we'd have to figure out a way to manufacture this stuff. We could do that. Sure. No problem. We'd have to basically test it from scratch. You'd have to do all the testing and all the dynamic testing, all the aerodynamic testing. You have to do all the load testing, acoustic testing. You'd have to do it all over again because the way you're making the engines and the stages are not how they were made 50 years ago. Could we do an exact copy and use old manufacturing techniques to make Saturn V? Yeah, sure, of course. Where are you going to get that? Where are you going to get that kind of work? That's a lot of skilled labor, dude. And labor ain't cheap in this day and age, man. Not like it was in the 60s, that's for sure. Here, I want to show you guys these pictures. There's a picture of Michoud. I have some really high-res 70mm pictures of where they built Saturn V's. You can see all the parts that they used. Like here's one of them. This is the S1B assembly line. Like, look, dude, you see there's no computers here. It's just a bunch of freaking blueprints. Bunch of blueprints and welding jigs, which is freaking cool, man. Materials are also different. So why develop SLS rather than bring back a proven craft? Well, John, because it's not proven. It's not proven anymore. It was proven with manufacturing techniques 50 years ago. You'd have to figure out modern ways to use modern manufacturing to make something from 50 years ago. That's hard to do. Now, here's the thing. A lot of people write it off as, it's hard to do. And it is. That's not wrong. It is difficult. It would be difficult to do, to make this all over again. But, I use the same argument that people would use, like, why build the Saturn V again? And why not use SLS instead? I use that same argument to say, well, why not build the Saturn V again? Because clearly when you're starting... Well, not even clearly, even I'm trying to think about it. Sorry, I started looking at this picture. I'm like, damn, that's a nice rocket. I'll just keep it up here. So, a lot of people say like, oh, why did we build SLS? It's easier to build SLS because it's a new design, right? It's easier to do that. It's easier to do that. It's easier to do that. And people say, oh, building the Saturn V would be more difficult because we'd have to figure out how to do all this stuff again. And I think that's really funny that people say something like that, because what they're telling me is that building building a rocket that's based off of a previously used spacecraft and adapted for modern use is expensive. That's the whole premise of that. Do you not see the irony in that statement? So you're telling me it's really expensive to take a previously flown spacecraft equipment, adapt it for modern use, and fly it as a reason why we shouldn't do that and why we should make SLS? I've seen people make this mistake all the time. And you don't think about it, right? It's on paper that's like, oh yeah, of course, we should build SLS. We can't build the Saturn V because it would be too hard to adapt manufacturing techniques to modern, to do modern manufacturing. Like we wouldn't be able to adapt the Saturn V to modern manufacturing. Well, you did it with SLS. You seem to have no problem doing that. And yes, it was expensive. So it seems like it's arbitrary at this point. Don't you think? You don't see the irony in that statement? I think that's really funny. That's hilarious to me. Think about how hard it is to go back into computer code you wrote 5 months ago. Yeah, there you go. What about the morons on Twixer who think canceling SLS for Starship is the right move? Oh, yes. Let's cancel a rocket that can actually, get something to the moon for a rocket that can't get something to the moon. Good idea. That's historically, points of view like that haven't completely screwed NASA from the inside out, right? Hey, let's swap the Saturn V, which can get something to the moon, with the space shuttle. It'll be cheaper. That point of view, oh yeah, no, that people have had that point of view in the past, and nothing bad ever happened. Hey guys, the Constellation program is awesome and could, really is a sustainable pathway forward to be able to explore the stars over the next 30 years. Hey, no. How about we use commercial providers who can't launch anything into orbit right now? Yeah, or who have launched into orbit once. That's a good idea. Yeah, let's do that. That's fine. Yeah, it'll be okay. Yeah, takes like that, Nova, have historically, takes like that have been, very cutting edge and very lucid about the state of the spaceflight industry. Nova, in case you haven't picked it up, what I'm trying to tell you is that people have no idea what they're talking about. Yeah, like no idea. They read a couple of spaceflight articles on Ars Technica, and now they're an expert. Or even worse, there's somebody that's like a software engineer and is like, I know about spaceflight economics. I'm a software engineer. Software engineering is difficult. Spaceflight economics are difficult. But I'm competent enough to know that my software engineering job will apply here fully. People do that all the time. Just because you're an expert on one thing doesn't mean you're an expert on another. How many times on Twitter, Nova, have you seen somebody say something that's an expert in their field and weigh it in on something they know nothing about and sound like a complete idiot? I can think of several times. Like, I've even heard certain STEM educators, like on the internet and on social media, talk about how science is a belief system. And I'm just like, the implication there is like science is some type of religion, which really pisses me off. I'm not going to name names. If you know, you know. Like, it's just that. No. Oh, yeah, some people in chat know. Right? Like, yeah. So, Nova, I don't like to answer questions with questions, but the next time you see somebody like that, if you feel like jumping into the lion's den or the zoo, because that's what Twixer is, it's a zoo. I think it's okay and healthy to go and observe the exhibits, but don't jump into the polar bear den just because you think polar bears are cool. Because you will get mauled by a polar bear on Twitter. No, if you feel like jumping into the lion's den, next time somebody says that, you say, oh yeah, because canceling rockets in the hope that they're going to replace they're going to be replaced by something that could be useful in the future has historically ended very, very well. Oh, wait. No, it hasn't. Right? Like, no, it hasn't. It's done the opposite of that. Trying to find those pictures of Michoud here. Here we go. Check this out, dude. You see any machinery here? You see any automation? Nah. It's just guys with welding jigs, welding stuff together. These are jigs for stage rings. Actually, those particular jigs right there are for the nacelles that covered the engines. How's it going, Mr. NASA? I hope you're having a good day in this world that has gone insane. Patton? Yeah. I'm always having a good day. You know why? I don't let the static bother me anymore. I don't let static bother me anymore, dude. You know, and if you want, you know, you want to be not want to be cynical and let, you know, the world get you down like that, dude, you freaking, you know, make the good times yourself. I'm happy because I don't let what people say bother me too much. Except if it's one of you guys and it's serious, not just screwing around with me. You see? Even look at the jigs. Look at these jigs. It's freaking... That one that has that... I think that's a forward skirt for an S1C. Look at the cart. The cart. Wood. It looks like a cart that you'd see in a mine in the 1800s. Isn't that crazy? Fun fact. The carts that they use now are still made out of wood. You know why? Static electricity. Static electricity, and if it was metal and you dropped aluminum on it or put aluminum on it, it could bend the aluminum. See? Bunch of guys TIG welding stuff together on jigs. That's old school fabrication, dude. And it worked every time. Crazy, right? But dude, like, see, that's the RP1 tank, that's the LOX tank. Even stir welding these things, and then isogrid composite interstages. So interstages on, like, say, Falcon 9, all right? The interstage on Falcon 9 that holds the first and second stage together, that's made out of the same material as a fairing. It's aluminum with carbon composite over it, right? Doing even optimizations like that, having carbon composite interstages on Saturn V. Carbon composite interstages, actually, that one might... The S1C, the load right there, you might want to still make that one out of aluminum. Would probably be a good idea. Even the thrust structure, you probably still want to make that aluminum, but I digress. Even if you took the RP1 and the LOX tank and used a milled ortho grid, like with 7,000 grade aluminum, and stir welded it together, you'd probably shave like 2,500, 3,000 pounds off of the stage mass. Which, if you have, what do I always say? Less rocket on your rocket, more fuel on your rocket, the further the rocket goes. Pretty straightforward. Or the faster it goes over a shorter distance. I mean, depending on how you want to look at it. Yeah, full. That's right, full tank. Yeah, the bead that you lay down with the TIG welder, you know, putting the rod through the arc from the tungsten rod, that's actually because it was manufactured in a different way than the metal that you're putting together. The bead actually ends up being stronger. Stir welding eliminates that. Stir welding, you don't have any bead. You have a stirring head, right, which basically just creates a ton of friction and just melts the aluminum together. That's why they do stir welding with rockets, because the molecular composition post-weld is uniform. There's no differential molecular composition between the two panels and where you weld it together with a stir weld. That's why. That's why it's so freaking useful. And stir welding, like TIG welding, is, despite using friction to kind of heat and stir the metal together, is actually a low heat application. So you don't have to worry about warping the aluminum like you would with a TIG welder. If you hopefully you touch the tungsten rod to the aluminum, you got a big problem. Well, go buy another tungsten rod. how do the old ways compare to how SpaceX welds Starship? Isn't that comparable? Well, SpaceX is still using automated jigs. Like I said, how they do this nowadays and how they did it in the 60s is not too far off. It's just the automation is such a big difference. They still use jigs like this, guys. Absolutely. They make a jig and they make sure that the tolerances on this jig, like that jig is perfectly level. It is perfectly flat. Like there is maybe a couple thou difference like on that ring. That ring is a perfect ring. Like now think about how difficult it actually would be to make something like that and not have the ring like bend or flex like this or like this, right? That thing is perfect. It is a perfectly level, perfectly cylindric. Because it had to be. Because when you go to put parts on this to try and put them together like this, right? If your jig isn't straight, well, your forward skirt is not going to be either, right? We still do that. We still do stuff like that. Only instead of having a guy get up on a ladder and start welding things together like these things over here, right? They have a machine do it. A machine with a robotic arm will just... That's how SpaceX does it. That's how everyone does it. No welding is done by hand. I mean, some of it does. So like on engines and stuff, there is some welding that is done by hand. There is some parts that are fabricated by hand. But yeah. It's the manufacturing human. The method is not too far off. I mean, in that, one last thing that I was thinking about saying, RE the Saturn V, I think we could. I think we could make a Saturn V nowadays. I think the challenges to overcome are not something that is completely insurmountable. I think people use that as an excuse to not pursuing harder options. Or as an excuse to do it with another rocket because we want to do this with this rocket because we make more money that way. It's probably that one too. I refuse to believe that we couldn't make a Saturn V again. Absolutely. No, we absolutely could. Duh. It would take a while. It wouldn't be something that gets done quick. It would take just as long as building another rocket that's a scratch-built design that would have the same capability. But that's always the justification that gets used. Well, if re-engineering a Saturn V right now, because you have to do all the testing over and over again, and all the modern manufacturing techniques are super different than the old manufacturing techniques, right? Because you have to do that all freaking again, right? You might as well just build a scratch-built rocket. That's always the justification, because you're not that much further along even reusing the old Saturn V design. Right? I think that once again, I think that that's the wrong way of looking at it. Clearly, we have no problem building launch vehicles out of old vehicle parts because we did it with SLS. So anybody that makes that argument is like, oh, well, SLS is a better rocket. I mean, don't get me wrong. I'll take SLS right now over trying to make a Saturn V. You know why? Because SLS flies. The Saturn V hasn't flown since 1973. I'll take the one that actually works right now. But if we go back 10 years, right? And we say, oh, what would be the best option? Do we build the Saturn V? We rebuild the Saturn V, rebuild SLS? I think that the justification that you'd have to, starting from scratch would be easier than trying to adapt the flown technology. Well, clearly it wasn't, because that's why SLS existed in the first place. So, I think we could do it. I think we absolutely could do it. Sure. I think we don't because, we don't for the exact same reasons why the Saturn V doesn't fly anymore in the first place. Why does SLS take so long? Murdoch, SLS is taking so long. First and foremost, it takes a long time to make a launch vehicle this big, and it takes a long time to flesh out lunar architecture. You could throw all the money in the world at this problem. It's still going to take 10 years. You know how I know? Kennedy's speech, "We choose to go to the moon," was in 1961 at Rice College. Right? Is it 61 or is it 62? I forget. And after Kennedy was assassinated, they basically gave him a blank check. The Apollo program really got kicked off like 63. Like, the Gemini and the Apollo program were kind of, I would argue that they're all one encompassed program, but nobody looks at it like that because you needed to do Gemini to get to Apollo. But that's a whole nother thing. So if you look at, right around where it was 62, thanks Novoraptor. You look at right around when the Apollo program got started to when you put people on the moon. This is with a blank check. 62, 63, 64, 65, 66, 67, 68, 69. Nice. Still took 7 years. Took 7 years with a blank check. Now, think about SLS now. SLS really, that design kind of coalesced in 2014, right? That's when the program really started to get off the ground. Not literally, or not actually, like figuratively got off the ground. And we saw the first SLS launch, Artemis 1, we saw it in 2022. So 8 years. With a program that's being funded at pretty much an eighth of the cost of the Apollo program. Just some food for thought there. To be honest, I think the biggest decider to adapt the shuttle hardware was that we supposedly still had the tooling to make it, supposedly. Yeah, that's what they thought, Aqualex, and then they realized that an external tank, a still-welded external tank that's designed to have a 62-ton orbiter on the side of it, does not bode the same structurally as a core stage tank having 4 engines at the bottom and a like 120, 130, 140 tons of upper stage and payload on top of it. Yeah, that doesn't take the load the same way. Oops. So they needed to invent new tooling to make SLS work. Oh, what was that? What was that about adapting old vehicles being difficult? Interesting, right? Yeah, that's weird. That's weird. Yeah, Dan, I'm great. How are you? Not bad. I always forget that they launched it already, right? I mean, once again, you hear people constantly hit, oh, SLS is too expensive, SLS this, SLS that. I mean, given the circumstances, I think SLS is doing just fine. It's taken less time to engineer, and it doesn't have a blank check. SLS was, believe it or not, over the last 10 years, was funded in probably the worst possible way that you could fund development of a vehicle. And I still say, to this day, that is, and make things out of clay and lay by the bay, I just may, what do you say? I still think to this day, that is, the way SLS was funded is going to have us end up spending more money than if we had just decided to give them a blank check. Literally, I think the way SLS is funded, a blank check and doing it Apollo style would end up being cheaper. Yep. Yeah, I said it. If you want me to explain, let me know. Would you like to know more? I can get into costs if you want, but that's entirely up to you guys. How hardcore of a rant about space do you want today? Yes. You want to develop an app? Well, can I ask questions about that? Sure you can. It's always the first step in app development. How much will your Kerbal SSTO cost the taxpayers? Privately funded. So, okay, I see some enthusiasm for the subject, okay? So, check this out. If I make a look at this graph, we have dollars here, right? And then you have delta T here. So this is time, right? And this is money. Okay? So you have 0, 0 here. So let's just say, let's look at the Apollo program, for instance, okay? So the Apollo program starts right here. And let's say it ends right over here, okay? So Murdoch, this is the ideal scenario. So this is the blank check, okay? So let's say, I'm going to make up some arbitrary numbers here. The point of this conversation is not necessarily the figures, right? It's not necessarily the figures. It's kind of, it'll make more sense. But like, these are arbitrary numbers for the sake of the argument. So say that's $5 billion or $10 billion or $15 billion. The Tres Comas Club. In billions. Right? And then you have over here, you have your time. So that's over here you have 5 years. And then here you have 10. And then here you have 15. Right? Okay? So, the Apollo program was funded something like this. You had a gigantic spike of funding during development. Well, why? Well, because designing something that goes to the moon ain't cheap, especially when you don't know how to do it. Okay? Okay? So, you had a crazy high initial investment right here. And if you look at NASA's budget, adjusted for inflation, even adjusted for inflation, if you look at it kind of, per capita, I guess? Per capita is not the right way to say it, but if you look at NASA's budgets at the time, budgets peaked for the Apollo program in 1967. Okay? So, right here, at the very peak of funding, that's 1967, right there, okay? 19G7. Okay, so that's 67 right there. Even in 68 and 69, NASA had their funding cut huge, like halved. Their budget was halved by the time Neil and Buzz landed on the moon. Apollo 11 would be like over here in 69. Nice, right? And then by the time Apollo 17 comes around, right? You're over here somewhere. And then the rest of this is Skylab and Apollo Soyuz test project. So you get right here 72, you get right here, 73, and then just pretend over here is 75, right? Like that. So you can clearly see that in this gap right here, those are lunar missions. Those are the lunar missions. So those are the 6 moon landings, 7 attempts right there. Right? If you want to go like even back here, there's Apollo 8 in 68. And then you go back a little bit more, 67, that's Apollo 4, right? And then a little bit later in 67, you have Apollo 6. Right? The whole point of this, and the whole point of why I'm trying to give context to this funding curve, right? The whole point why I'm trying to give context here is because funding peaked basically at the first test flight. Okay? That is super important in launch vehicle development. Because once you start getting into operational tests, costs should start going down. The reason why costs should start going down is because a test flight is very close to being operational. And if your test flight validates your results, you can quickly make the pivot to operational missions, even though those operational missions are complicated. It turns out building rockets, or developing rockets, is more expensive than building and flying them. Look at NASA's budget from where I marked Apollo 8 in 1968 to 72. This right here is what the budget would look like just building and flying Saturn V's. No new development, or just minuscule amounts of development, small iterative changes. That's what that funding curve looks like. And keep in mind, in 1972, right, the Apollo program, the funding for the Apollo program actually went more like this, right? The reason why is because NASA was funding the development of another vehicle, albeit on a much smaller budget. So even with the funding slashed because all the money is going into developing a new launch vehicle, the Apollo program was still capable of achieving operations at a very, very low cost comparatively to development, right? Yeah. NASA's funding for the Apollo program basically in 1973 went because they tried to ramp up shuttle development. They tried to build a vehicle more complicated than Saturn V for a quarter of the Saturn V's development budget. Fun fact. Yeah, that ended about as good as you think it would, right? So now let's look at SLS funding. So this is SLS funding. So right here, this is in this scale right here, that's 2014. Okay? Want to see how SLS's funding goes? Starts off pretty good. Actually, sorry, that's not exactly right. It starts off up here. Pretty good. Overfunded. Stuff gets done really, really quickly. 2013, 2014, you hear a lot about the launch vehicle. And then basically from 2015 to 2018, 2019, we hear nothing. You know why? Funding didn't do this. That's for sure. If you look at SLS's funding over the last 10 years, it's linear and combating inflation. SLS's budget went like this. And then maybe peaked a little bit right after 10 years. And right here is basically where we're at. Actually, it's more like we're right here. Do you see something wrong with that? Development is the most expensive part of any vehicle testing, by a long shot. You know why? Because no one knows how complicated it is to build a lunar vehicle. To build something that gets to the moon. What experience do we have building and developing super heavy launch vehicles? Oh, the Saturn V? Yeah, most of the people that worked on that are dead. Or if they're around, they could help maybe a little bit, right? But most of the institutional knowledge for that that ship sailed away a long time ago. To half the Saturn funding? No. Actually, it's probably more like this. Squall? Maybe like that at best. And maybe there was a little bump in 2018. So that would have been 4 years after. So the development probably would have been like this. Somewhere like that. But we're 10 years out, so... let me just draw this line one more time. Little bump in funding, and then basically this. Right? Because it's 2013, 2014, so we're right around here somewhere. The Artemis 1 mission was last year, so it was right there. That's your first test flight. See what I'm talking about? If you don't see it, let me explain. So, let's look right here. Take this and just look at the, surface area of this thing, right? Take a look at all, like, the physical space that arc covers, okay? If you take this and you squish it, right? Where does the operational mission go? You take it, you squish it, you try to fit this arc into the blue area right here. Where does that go? Well, you're going to squish it, you're going to try to move it. You ain't moving it this way, right? You got to squish it and move that way. You know why? Because schedules and timelines only move in one direction, right? So this, you try to squish it all in here. This surface area ends up fitting almost pretty much exactly with this surface area right here. See what I'm talking about? If SLS was funded correctly, and my theories about what's funded correctly and what isn't funded correctly is not my opinion on the subject matter. It's straight out of NASA's systems engineering notebook of what the ideal funding for a project is. If SLS was funded correctly, it probably would have flown in 2017, 2018. 4 or 5 years. First test flight, 4 to 5 years for a super heavy launch vehicle after the program was started, which is pretty much in line with the Apollo program. But since it wasn't, and SLS has basically been funded on a linear budget that's just designed to increase to combat inflation, Your first test flight's going to get pushed out a lot further. We're saddlebagging the development of SLS, right, into the operations, which I think is insane. I think that's really stupid. The reason why is because you're making major architectural changes to the vehicle over the course of its development, like adding a bigger upper stage, Block 1B, or Block 2, adding composite boosters. Now, those are viable pathways for SLS that they could pursue in the future. But there's this thing. The more you change a vehicle, like very big architectural changes, like a different upper stage or different boosters, the further down the project you change the architecture of the vehicle, the more money it's going to cost. You don't see SpaceX trying to make a bigger upper stage for Falcon right now. You know why? Because that's a losing way to do things. That's going to cost way more freaking money. You're already stretching Falcon 9's design to the maximum. It'd be better to just start over and build a bigger launch vehicle, Starship, right? You don't see SpaceX making any changes to Falcon 9. Part of the reason why Falcon 9 is so cheap is because it can be mass produced, right? Because it's not a complicated vehicle comparatively to like SLS or even Starship, right? Falcon 9, Falcon, Dolphin and Whale. Most of the major architectural changes to Falcon 9, like extending the upper stage and extending the first stage to allow for vehicle landing, so Falcon 9 1.1, were made within 5 years of the program being established. Falcon 9 came on the books for SpaceX in 2008 after they got a commercial orbital transport services contract from NASA, which literally saved SpaceX. SpaceX was like Astra at one point, guys. And I'm not trying to knock on Astra. I think Astra's cool. I think that's a very talented bunch, and I don't think they get the credit that they deserve. They literally built a rocket out of just common materials, and it made it into space once or twice. That was Astra's whole thing, making a rocket out of materials that are easily accessible to make a lot of them. That's like, okay, so think about it like this. That's like going down to Home Depot and buying the sheet metal at Home Depot or Lowe's or your local hardware store and building a rocket out of it. Okay, you try doing that. Building aerospace vehicles out of non-aerospace grade materials is a very hard thing to solve, like building rockets out of stainless steel. How many times has SpaceX popped one of these things? In flight and on the ground. Right? So, the point that I'm trying to get at is that most of Falcon 9's development, all subsequent Falcon 9 architecture, is based off of Falcon 9 1.1, which came around in 2013 with the Cassiope launch. Right? You haven't seen many major architectural changes to Falcon since. The only architectural changes that we have seen or are going to see is obviously the Dragon capsule, the Dragon 2 capsule on top, which isn't a change to the launch vehicle too much. And Falcon Heavy, which Elon himself has said building Falcon Heavy was almost to the point where that would have been a waste of time. They built Falcon Heavy instead of trying to start building Starship, and like I said, Elon and Gwen both said that's like, maybe we shouldn't have done that. Because changing vehicle architecture after you kind of have a really good baseline design is really stupid. That gets really expensive. And the further down the line, the further down the line that you do that, the worse it gets. You know why? Because now you're moving you're moving away from operations. You're moving away from the operational cycle here. Right? You're moving away from this part, the part where you actually spend less money to do more because you got what you paid for. Developing SLS, right? Changing the upper stage after operational missions is the stupidest thing I've ever heard. Like that, it's funny because NASA invented this architecture, and it literally goes against everything that NASA wrote in a book about how to fund launch programs correctly. Nothing that I'm saying here is my idea. This is all out of NASA's systems engineering handbook, and it has proven time and time again to be useful, right? So this is what I mean when I say, if SLS funding had even done something like this, you don't need to spend as much as the Apollo program. You know why? Because your launch pads are already made. Your integration buildings are already made. Your factory is already made. Michoud didn't come cheap. That's a big facility. And the Apollo program had to eat the cost of building these facilities to manufacture 10-meter cores. And the launch pads, and the VAB, all the infrastructure to move Saturn V's around, turning basin, crawler way, everything. The ports, all the infrastructure that you need, the heavy infrastructure that you need to put out in the middle of Merritt Island, in the middle of nowhere. All of that, Stennis, the test stands, Marshall with the dynamic testing stands, all of that got roped into the budget, right? So that's why that gets so expensive. But SLS already has those at their disposal. Even if they had funded it to the tune of half, even adjusted for inflation, of what the Apollo program would have been, we'd be on the moon by now. Easily on the moon. And this isn't just my speculation. This is, once again, it's based off of NASA's systems engineering handbook and timelines. Like, I read that book a lot because I'm a loser, and that's what I like doing with my free time. I know, I'm weird. I get it. Right? So the second you enter operational costs is the second you're basically paying for this technical debt right here. And the more you can get out of a vehicle after it's been developed, the more these dollars right here spent in the beginning of the program will take you further. Because SLS is not doing that, if you wanted to right the ship at this point, so once again, say the ideal funding curve for SLS looks like something like this, right? Well, look at the problem here. See this? You're taking this surface area and you're plopping it down here, so it's going to take longer. But once again, yeah, say this was the ideal funding curve, right? Sorry, I changed the subject a little bit, right? Say that was the ideal funding curve. Well, guess what? You put another upper stage on the vehicle. The whole thing needs to be tested again. And we're going to test it with people on it with a new upper stage on the first try, which, okay. They didn't even do that with Saturn V, but hey, whatever. What do I know? Right? You really want to right the ship with SLS. Guess what? You're funding, even at this point, so I'm talking like a block buy. All the facilities and manufacturing suppliers to, enter that operational phase where the costs will go down. Guess what? It's got to look something like this. If you really wanted to fix everything. And I'm not just saying throwing money at the problem is going to fix it, because it's not. This is based off of the predication that somebody that's running this that would be able to pull a funding bump like this actually knows what they're doing. And not to imply that NASA doesn't know what they're doing. Their hands are tied because it's a much more complicated issue than just give NASA more money. I understand that. But if, that's what you'd need to do at this point, because once again, you got a new upper stage that needs to be made. With that comes a new payload adapter, the universal stage adapter. So that needs to be funded. And if you wanted it done on a reasonable time frame, you're going to have to spend money now, right? And they're talking about incorporating Block 2, changing the SRBs on SLS in the future. Right? So SLS, with all these bumps, all these parts that need to be redesigned, is going to end up being up here somewhere. And then down here, only down here, is where you're going to get into operational missions. Once again, you tried to squish that red curve into this. And look, I at this point, right? At this point right here, we're going to be 15 years out of the gates with this thing at the end of this decade, right? And what are we going to have to show for it? Right? Maybe, hopefully Gateway's up and running by the end of the decade. That's not bad. Right? But I'd be interested to see what the total volume of this area is right here versus this. I'll bet you Apollo is, if you adjust for inflation, I'll bet you Apollo ends up cheaper than SLS after 15 years. Because, after 15 years, we can't really compare it to anything because the Apollo program was sacked after 15 years. I bet you total cost incurred is going to end up being more than Apollo. I'd be willing to put money on that, taxpayer money, because SLS needs more of it. See what I'm talking about? Why is SLS taking so long? Because it's literally, they funded it in a way that is quite possibly the worst way to fund rocket development. You're just basically trickling funds at the same rate, on a linear rate, over the course of 10 years. That is not how you run space programs. Yeah, that's not how you run space programs at all. That's bad. So think about it like this, and this is why people use the SLS program. This is why people hate it. That's the reason. That's the reason why people don't like it. SLS, after 15 years, is going to end up, adjusted for inflation, spending almost as much money as the Apollo program and doing way less. Because remember, after 10 years' time, 1973, Apollo landed on the moon 6 times. 9 missions out of low Earth orbit. So Apollo 8, Apollo 9, Apollo 10, 11, 12, 13, 14, 15, 16, and 17. All right? 6 of those landed on the moon. There's the fiasco with 13. Apollo 8 was a circumlunar navigation, and Apollo 10 was basically an Apollo 10 was basically Apollo 11, except without the landing. Get out to the moon, separate from the LEM, circle down to the landing orbit, and then just come right back up and dock and go home. This is why people don't like what SLS is doing. It's funny because even the people that don't like it don't know the reason why they don't like it. That's the reason. For what it's worth, I do like it. You know why? Because I'd rather have this than nothing. And that right there, we're going to do a little bit of a pivot here. That right there, what I just said, is the reason why SLS funding is the way that it is. Would you rather have nothing? That's the question to ask. Would you rather have nothing? Would you rather have nothing getting to the moon? Because, well, that's what we almost got. Let me explain. So, it's 2011. Constellation gets canned. Space Shuttle gets retired. The reason why Constellation got canned, the stated thing was that it was going to cost too much money. Any lunar program is going to cost at least $30 billion, at the very least. But somehow the executive branch thought that their hopes and dreams were better than, could beat the laws of physics. But I digress. It's funny how that works. So one of the cited reasons of canceling Constellation was that they pulled the plug on it. They pulled the plug on it because it was too expensive. It was too expensive. Well, once again, going to the moon or developing architecture to get to the moon is not something where if you're cash strapped, that you should probably be doing. So the executive branch does denote what NASA is supposed to do, right? That's the executive branch denotes what the goal is, and Congress will fund it, right? Up until this point, vehicle architecture, vehicle engineering, the design requirements for what launch vehicles you're using and what you're building was denoted by NASA. NASA designed Constellation. NASA designed Ares 1 and Ares 5. And the idea was that because the shuttle was still flying, using shuttle components, good idea. That way you could transfer personnel slowly over to Constellation as you ramp down funding of the shuttle and ramp up development funding of Constellation, which is pretty much what was happening until 2011. 2011, they look at how much this thing is going to cost overall. They look at that big red arch that I showed you guys at the Apollo program and say, no, we're not doing that. Let's leave it to commercial. Commercial endeavors doing this would be better, right? And at the time, we got projects like Commercial Crew. that's the time when Commercial Crew came around and the idea of private companies moving NASA astronauts to the ISS. That's when that idea gained popularity. But just remember this. There's an asterisk next to that statement. Okay? We'll revisit that later. So, how does this have to do with us having nothing? How does that work? Well, the executive branch decides NASA's goals. And the executive branch suddenly decided that NASA didn't need to exist. NASA human spaceflight didn't need to exist anymore because you could just give it to commercial endeavors and make it cheaper. Maybe in the long run. Once again, there's that asterisk, right? Congress got wind of this and they freaked the hell out. They freaked out. They said, you want to just can our entire national space program. So Ares 1, Ares 5, the lunar landers, all of it. You want to just can all of that. And it said, yeah, that's what we should do. And they said, are you out of your frigging mind? So Congress did something that was a little bit unprecedented at the time. The executive branch said, we shouldn't do the Constellation program. Come up with something different. Or just give it to commercial. Let SpaceX do it. Which, once again, nowadays, that wouldn't be a bad idea. I still say that NASA should have their own rockets, but nowadays it wouldn't be a bad idea. But you got to remember, in 2011, SpaceX had launched one Falcon 9 to orbit with a Dragon capsule. That's it. Hadn't gone to the ISS, and most of their rockets failed. They had more failures at that point than successes. So they said, just have commercial endeavors do the whole thing. They'll do the whole thing. Okay. Congress freaked out and said, "Yeah, no, you're not gutting our national space program. That's entirely stupid. We have all these facilities set up, and it employs thousands of freaking people across like 40 states or something. Like we're talking about getting rid of like probably about 50,000 NASA employees, right? That's insane. And you got to remember, it's 2011. We're reeling from the Great Recession. Congress looked at that and they said, that's stupid. That is really stupid. We should not do that. That's a really bad idea. So, the executive branch said, well, that's what I want to do. And Congress said, fine, frick you. And you know what they did? They designed it by committee and made the design requirements for SLS, because Constellation that ship already sailed, that ship was gone. So in response to that, they designed the rocket by committee and had politicians design a vehicle for NASA to put it in as law so the executive branch couldn't get rid of it. Think about that for a second. Design by committee is awful. That's the worst way. Bureaucracy designing, implementing and engineering systems design is the stupidest way to do that. But once again, it goes back to the whole premise of the argument. Would you rather have nothing? Because that's what we almost had. Would you rather have nothing? Where would our lunar aspirations be if SLS didn't exist right now? Nowhere. It would have been an extremely long time. Hi, I'm from Germany. Hey, Kevin. Mondland gifted 10 subs. Thank you. Dude, you've been too good to me lately. I do appreciate it.
Discovery, go at
Where would we have gone? We would have gone. We'd be nowhere. So Congress implemented that design because we almost had nothing. They actually saved
Discovery,
NASA's human spaceflight program. They saved it. And it's funny because in this day and age, I get it. It's really fun to bash. It's really fun to bash Congress and say they're useless, etc., etc. But in the context of this particular situation, again. In the context of this particular situation, they saved NASA's human spaceflight program. NASA would have nothing.
Discovery, go at throttle up.
No Artemis program. No SpaceX lunar lander. No SLS. None of that would exist if Congress hadn't implemented a design.
Discovery, go at throttle up.
Mondland again. Thank you so much, dude. I do appreciate it. None of this stuff would exist if Congress didn't design to implement SLS into law. Mandating by law that you have to use shuttle engines. They did that because they had the rug pulled out underneath from them. And then they funded it and signed it into law.
Discovery, go at throttle up.
Because we almost had nothing. It was close. Monblend, 4 more subs? Jeez. That brings it to an even 100. Thank
Discovery.
you. Broken clock is right twice a day, I guess. Hey, midget, I'll take broken clock being right twice a day versus a clock that's smashed and thrown on the ground. That's destroyed, right? Like, I'll take that. That's fine. It's better than nothing. So think about that next time you go bashing SLS. The reason why SLS exists is because they tried to pull the plug, the executive branch tried to pull the plug on the entire thing. They tried to pull the plug on the whole thing. And Congress freaked out and said, no, that's really stupid. Because laying off 50,000 contractors while we're reeling from a recession is a really stupid idea. So it's important to understand the context. In this particular case, Congress saved NASA's human spaceflight program. We would be nowhere near going to the moon in the next 5 years, in the next 10 years, if Congress didn't step in and mandate a design by committee. Just saying. It's not at all what we should have had, but it's better than what we almost had. Bingo. Bingo. And that's why, despite SLS's funding problems, and basically Congress said that we're going to fund it to this tune, and it's law, and there's nothing you can do about it. Because the executive branch tried to pull the plug on the whole thing, which is borderline unconstitutional, but they do control what NASA's goals are. But that was, whatever. Hey, that was a long time ago. But it's important to understand the context there of why that is the way that it is. Because we almost had nothing. So I'll take SLS with its crappy funding, with its completely stupid design by committee, and, architectural changes 10 years down the line with the program, changing upper stages, changing boosters, etc., etc. I'll take all that over nothing. You can't make money from it unlike Warren investing in stocks. NASA is not good for necessarily making profit random. What NASA is good for is building infrastructure. Think about it. Look at something like the Cape. Look at something like Kennedy Space Center. How many people use the causeways that were built during the Apollo program to get out to Merritt Island? How many people use those for vacation, for getting to Port Canaveral for cruise ships? How many people use the facilities, the dock at Port Canaveral? That was built, the dock at Port Canaveral was built so we could ship Apollo hardware to the turning basin in the VAB. The Port Canaveral locks, the entirety of Port Canaveral, deep water port there. How much money does that port end up bringing in? Because it was built by the Apollo program. How much tourism does the Cape bring in from people who want to see launches? Now that's hotels. That's hotels in Titusville. That's hotels at Port Canaveral. That's hotels in Cocoa Beach. All those people have to go somewhere. All those people have to eat. Right? How much it's a tourism freaking cash cow. NASA's great at building infrastructure down here. It's great for developing underdeveloped areas, and that's basically what the Apollo program did. It built up infrastructure in areas that had none. It's a really good idea. Think about how underdeveloped the South was in the 60s. Yet we have Stennis, Marshall, Michoud, Kennedy. There's a reason for that. Johnson Space Center in Texas. Go look at there on Google Earth. You can go look at what was around Ellington Field when the Apollo program started. You look at it now, Johnson Space Center is ridiculous. It's a freaking powerhouse. That's what NASA's really freaking good at. Now, you get infrastructure built, you get infrastructure built down on the ground, and the extra part of that makes it really cool is that we get to go expand our scientific understanding and better understand our place in the universe and go and explore, because that's what we do. We humans are curious. That we figure things out. We like to do that. We're pretty damn good at it. How a storm works. It was fun, Binal, yeah. I'd argue that NASA is wonderful in terms of making profit. The problem is that it's not the whole mechanism. Looking at NASA or USPS to turn a profit is like looking at an ISP's IT department and saying it's just a money sink. Aqualix, I don't know if I probably didn't lay it on enough. That's what I'm saying. There's no visible profit. You can't just say, this NASA project I put $20 billion into and we made $40 billion of profit. The profit comes from other things, like a bridge, or a lock, or a heavy infrastructure port, or all the people that need to live around the Space Center to get the Space Center to do. I explained it in a slightly different way than you did, but that's the point that I'm getting at. So, yeah, we almost had nothing. How much would it kill people right now if 39A and 39B were doing nothing? 39A would probably still end up getting leased to SpaceX because 39A was doing nothing until SpaceX got a hold of it. But if we hadn't canceled Constellation, 39A would be launching a 10-meter, 5-segment solid rocket booster, super heavy launch vehicle that can move like twice what the Saturn V could out to the moon right now. We'd probably be testing Ares 5 right around now. So, but yeah, if Congress didn't force SLS, if they didn't force the design into law and then force the funding for it, how much would it kill you to see the VAB not being used right now? That would suck. Would you rather have that? Even with how successful SpaceX is, I would not want to see that. That still pisses me off. There's one high bay inside of the VAB, high bay 1, that hasn't been used since the shuttle program. Literally, the last time anybody set foot in there to do any spaceflight operations was July of 2011. It's just been sitting there doing nothing since. Even that pisses me off. I'm like, you spent all that money to build that damn freaking gigantic high bay that's designed to put moon rockets together and space shuttles, and it's doing nothing. It's really, maybe it'll be doing something in the future. The other 3 high bays are being used for SLS, which I think was a stroke of genius by NASA, to be honest. 2 of the high bays in the VAB are being used to manufacture future versions of SLS, and 1 of them is being used to build it. Pretty cool, actually. Oh, the taxes on computers says the incomes of people working at ULA. Yeah, exactly, Aqualex. It's great at building infrastructure. You're going to see a return on investment, but it's not going to be just more money in like the government's bank account. I mean, actually, it might be with taxes, but yeah, it's not like a short-term thing, you know? But yeah, we almost had none of that. There's a timeline, a dark timeline, darker than where we're at right now, where we don't have any of that. That's not good. I wouldn't. Do you want that? I wouldn't want that. Once again, that's why anybody, you know, if anybody comes around and said SLS is too expensive, that is grossly simplifying why the SLS program the way that it is, and demonstrates that, you know, if you say a statement like that, I can immediately tell that you know nothing. Like, that is, you read 1 or 2 threads on Reddit, now you're an expert on funding space programs. I really try to combat that behavior as much as I can, because the same type of people that think they're helping by saying SLS is a waste of money and need to be canceled are the same type of people that said that the space shuttle is a better design than the Saturn V, and, you know, well, it could go further. It could be better than the Saturn V, and it's way cheaper. Yeah, how did that turn out? Oops. Starship still needs an integration building in Florida. We can hope. So, yeah, Murdoch, if you're still here, he's the one that originally asked the question about why SLS is taking so long. There's your long format answer, right there. But it's important to understand why those lines are the way that they are. You want me to save that? Save the file? All right. I like drawing out the graph every time. I think it's better to do it that way. It's better for a lesson plan to draw it out and understand why I'm drawing it the way that it is, but I'll still save it if you want. Here. Less money takes more longer. Yep. But the reason why it's funded that way, if you want to collapse it down, less funding for a super heavy launch vehicle just means it's going to take longer to make, because it's a zero sum game roundabout. You want to start, if we started a lunar program right now, even me, who is not the best at like understanding this whole process and how it all works, but even a conservative estimate for me, if we wanted to start it from scratch and like rebuild the Saturn V and do the Apollo program over again, 10 years, $30 billion. Easily. Yep. You want to do any lunar program, that's pretty much the running price tag for developing something to get you that far, even remotely reliably. Yeah. So, funding it to the tune of less money is just going to make it's just going to take longer to do the exact same thing, because it's a zero-sum game. But the reason why it's funded that way is because we almost had nothing. That's the short answer. To be honest, okay, hold on. Clayton, how's your Friday the 13th going? Not bad, just here doing some remodeling, removing old carpet to save money. Nice, there you go. Alex, to be honest, I want to see someone estimate the tax revenue from all the technology Apollo developed and show where we would be in terms of budget, so we can point that as to why NASA isn't a waste. You need look no further than the smartphone industry. What are the profits that Apple makes off iPhones, or Samsung makes off Galaxies? Miniaturization of digital electronics has the Apollo program to thank for that. There's no way we would have smartphones right now if it wasn't for the Apollo program, straight up. Yeah, optics. That's right, Helzikin. Yeah. Optics for engineering cameras, optics for taking pictures on the moon, Hasselblad cameras. I think that optics might be better, but I don't think we'd have DSLRs. Because once again, miniaturization of digital processors, basically making computers tiny. The Apollo program had to do that. They had to do that because they needed to get a computer that was sophisticated and smart enough to be able to get you near the moon, and then also actually be on the spacecraft. You want to know what they did before that? They either had a bunch of partially semi-digital systems, like on a Gemini capsule, or full analog, like Mercury. The early ICBMs from the late 50s, early 60s. You want to know how the guidance worked on those? They didn't even put the computer on the vehicle. The computer was in a freaking building that was the size of like my garage, and the computer was in there, and they basically transmitted the guide. It was basically remote control. It was radio control. Early ICBM guidance systems were radio control. Basically a computer, like I said, that's the size of a semi-truck, sitting on the ground communicating with the vehicle after it's launched, telling it what to do. Yep. That's how rocket guidance worked before the Apollo program. Well, it's easily jammable. It's not that big of a deal, Random, because by the time you get to main engine cutoff, by the time you get to MECO, you don't need to control it from there. It's called an ICBM for a reason, ballistic missile. Basically, you send it. When the rocket's under propulsion, it basically goes where you want it to go, and then once it shuts off, that's it. It's just ballistic from there. Just deploy the payload, it'll come down and do its thing. So it's only, they still have acquisition of signal while the ICBM is going up. And when it flames out, you still have AOS. But they don't do that. The missiles have guidance computers on them nowadays. And once again, you have the Apollo program to thank for that. They made the decision with the Apollo with the Saturn V that how the hell are you going to beam? Are you going to fly it by hand? Well, the Gemini program proved that you could, but that would be very unpreferable. You could navigate through space with a naval sextant just by looking at the stars, because the way the sky looks doesn't change just because you're 200 miles that way. Heck, it still doesn't change even if you're 250,000 miles that way. You can use a sextant to plot your course, to figure out your orbit. Buzz Aldrin is the guy that figured that out. Yeah, he wrote a thesis on that for his doctorate at MIT. That and cycler orbits too. But that's another story. Yeah, W, that's cool. How's your Friday the 13th going? I feel like I'm having weird deja vu. That's how it's going, Clayton. I feel like I'm having deja vu because you asked me that a second ago and I answered, and then you asked me it again. Nice t-shirt. Where'd you get it? I get it from a guy that I know. He's kind of a jerk, though, but it's alright. I deal with him. So, yeah, I mean, you want to tally the cost? Digital processing. Look at like AWS, just web services, server racks, stuff like that. That can all be traced back to the Apollo program. So like having a CPU, RAM, hard drives, that all comes from the Apollo program because they were trying to miniaturize a computer enough to be able and make it light enough to be able to put it on a spacecraft. You notice how after the Apollo program, 75, 76, you started seeing personal computers come around? That's no coincidence. If the computer is in a building, at least you can't install it upside down. That's a really good point, Snake. You're not wrong. Curious Mark on YouTube has a series restoring an Apollo guidance computer, which I thought was quite interesting. Jamka, that's one of my all-time favorite series on YouTube. And then they took the AGC that they found and used a Raspberry Pi to interpolate its command output into Orbiter, into a lunar simulation mod that was built for Orbiter. And the AGC, using a Raspberry Pi as an intermediary, landed a LEM on the moon in Orbiter in a video game. Now that's cool. That is like next level cool. I still think that is one of the coolest things I've ever seen on the internet, man. Yeah. So just in case it needs to be reiterated, in case anybody heard that at the tail end, there's a YouTube channel called Curious Mark. Curious Mark is a bunch of guys, a team of nerds, right? And just through sheer dumb luck, they bid on an Apollo guidance computer at a government auction and got one of the Apollo guidance computers that is flight fidelity that was used for ground testing during the Apollo program. It is identical to the ones that Neil and Buzz had on their rocket and all the rest of the astronauts that went up to the moon. It's identical. But they used it for ground testing. It's one of the few cases where you have a fully intact AGC, Apollo guidance computer. They took that thing, fixed it. First of all, they restored it, got it working, and then used a Raspberry Pi to get it to plug into a computer and fly a LEM simulator down. And it landed in Orbiter. So it's the lunar mod for Orbiter. It landed it on the moon. The AGC was controlling the video game on another computer, and it landed it. Which was freaking awesome. That is one of the coolest YouTube videos I've ever seen. That's right up with digging a tunnel in your backyard. Yeah. Yep. About YouTube. Ad time. Okay. Anyway. Yeah, it's one of the coolest YouTube series I've ever watched. Computer restoration. That's weird, man. I know that's a weird term. Oh yeah, Binky is up there too, Midget. Nick and Rich are... You know what, Midget? Nick and Rich could probably build a rocket and fly it into space. It would just take 25 years for them to do it. But I guarantee you that they are competent enough to do it. Urban Venture, raid message. What's going on, Urban Venture Raiders? Thank you for the raid. Wait, they hooked up an AGC to Orbiter and it landed itself. You want the link? Here, I'll show you. Curious Mark is a bunch of nerds that restore old electronics, but the guidance computer is one of the coolest things. I gotta find it here. It's on one of these playlists. AGC Resto. It's part 23. Right there. Thank you, W. So yeah, here, watch this. So the AGC is plugged into a Raspberry Pi, which basically takes the output. It's plugged into a little computer, which takes the output of the guidance computer and puts it into the lunar, puts it into Orbiter. I won't show you the whole video, but I'm trying to see if we have a picture of the whole damn thing. But yeah, look. Frickin' son of a gun's flying itself. Look. It's doing its thing. Yeah, see? There it is. It's right in the beginning, see? There's the AGC. There's the I/O panel. So that's flight management system input. See? It's just doing its thing. Is it an Arduino? It's an yeah, it could be an Arduino or a Raspberry Pi. Yeah, I always get the two confused, but yeah, there you go. Microcontroller is probably the application that makes more sense. Apologies. Yeah, so what the dude is doing is he's inputting the landing program into the LEM. Just plug it in, right? He's actually pushing the buttons, and the button, you know, that's showing up there, see, P63, that's the program. P63, if I'm remembering right, is the initiation of PDI, powered descent, which basically the start of a landing. If I'm remembering right. Or it's part of the landing cycle. I'm kind of looking at the caption here. It's not exactly the same thing, but yeah, see. Watch the whole video, dudes. I'm telling you, it's fascinating to see it. See? Computer's just doing its thing. Imagine being able to use the AGC for a KSP setup. I mean, I suppose you could get the Arduino to input the controls. It shouldn't be an issue, but you'd need to use KRPC to code in all the systems that the AGC needs to understand where it is. But yeah, it's crazy. They got a 50-year-old computer talking to a modern computer and playing a video game that was coded almost a half century after the original computer was made. Is that wild or what? Anyway, Urban, hey, thanks for... Yeah, also just for the size of the Kerbal Moon. Yeah. Urban, thanks for the raid, man. Illumination site at... Yep. Illumination at the site, early moon morning, was chosen so the astronauts could see the shadow. Yep. No problem, buddy. How's the project going? Good, man. Just doing good. I'm kind of pacing myself here because, anyway, yeah, here, let me post the link to this, dude. I'm pacing myself because today's going to be a long stream. I've been going since pretty much 9, and we're going to be going, well to 9, so it's going to be at least a 12-hour stream today. So, yeah. We can get into development of the vehicle now. You hear those nice Kerbal burbs in the background there. Let me turn that down. Let me go over